So let's look at genetic diseases. We're going to focus on one type of genetic disease, particularly nasty one called cystic fibrosis, sometimes referred to as CF. Now, this is an interesting condition because it's a rarer condition because it's recessive. So that means both parents need to be carrying the allele for cystic fibrosis. Not necessarily have cystic fibrosis themselves, but be carrying the allele. And then there's a chance that the child will have cystic fibrosis, and we'll look at that later. But roughly at the moment, today, it affects about 10,000 people in the UK. So quite a low number. If you look at the population of the UK, is probably over 50 million. There's only 10,000 people with the disease. Recessive conditions are rarer because you need both alleles from both parents. Now, of course, if both parents had cystic fibrosis, it's probably highly unlikely they'll go on and have a child because they'd be putting that on their child. Okay, so it would be a very difficult childhood. There's no cure for cystic fibrosis, there's only ongoing treatments. Now, it's caused by a faulty gene, and the gene basically codes for the production of mucus in your breathing airways. Okay, these passages. So in this diagram here, you can see you've got your trachea. It branches off into the bronchus. Okay, let me just zoom in a little bit. That's better. So you've got the trachea here. So the air comes down here, branches off left and right into the bronchus or bronchi, and then these tiny tubes are called bronchioles, and at the end of each bronchiole you've got your air sac, your alveoli. That's where the gases exchange. Naturally there'll be a layer of mucus lining these airways because that traps dust, microbes that are in the air that we breathe in, and then we can cough them up and we can remove them from the body. Now, the problem with cystic fibrosis is those cells are almost on overdrive because of this faulty gene, and they produce too much mucus. So if you look at these two diagrams here on the left hand side, this one here, this is a normal healthy airway, and you can see you've got a nice wide central space there for the air to pass through. And this one here, this is the person that's suffering from cystic fibrosis, so you can see this excess mucus has been built up. So you've got this narrowing of the tube, so it's going to be very, very difficult because of this restriction for the air to actually flow through. So somebody that's actually living with cystic fibrosis will find it very, very difficult to breathe normally. Okay. Now, like I said before, there's no cure. There is a couple of things you can do to kind of cope with this and at least make your life a little bit easier. There's medication, and there's also use of physiotherapy. Now, the medications tend to be medicines that will thin the mucus out. They can be very similar to inhalers that asthmatics use, which will try to relax the muscles around the airways and will open them up a little bit wider. And the physiotherapy basically is a form of massage where the back is rubbed and massaged to encourage the removal of any excess fluid. So that's the basics behind what causes the cystic fibrosis and any forms of treatment. Now, if you do want to find out anything more about cystic fibrosis, there's a nice website, www.cysticfibrosis.org.uk. Okay, and they've got all sorts of information there about how to cope with it, living with it, interviews, etc. Okay. Now let's just go back to some of our work we did in it earlier on with Mendel's Punnett squares, because you can use these a lot to make predictions. So in these Punnett squares, I'm going to have two scenarios. I'm going to put the father at the top and then the mother on the side, just so you know. And I'm going to use the letter F for fibrosis, okay, because it's easy to distinguish between the capital F and the lowercase f. So the big F is for a healthy gene. Okay, remember this is a recessive condition, so we give that the lowercase letter, and in this case little f is for cystic fibrosis. I've highlighted that in red just so it stands out a little bit more. Now you could in theory use any letter you like, guys. C's sometimes are used, but sometimes it's difficult to tell the difference between a capital C and a lowercase c. So just be aware of that. So let's imagine we've got two parents. The father is perfectly healthy, not even carrying the allele for cystic fibrosis. Okay, so there's been no history of cystic fibrosis in his family, his side of the family. The mother, however, is a carrier. Okay, so what that means is because she's got the big F, she's healthy. She doesn't produce excess mucus. Okay, but she's got this recessive allele for the little f for the cystic fibrosis. Now she might not even know she's got this, okay, unless there's any history. People are aware of this in a family, and she's got a history of cystic fibrosis somewhere in her past, but she might not be aware of that, okay, unless she has some form of medical screening. Now what's going to happen is those two big F's are going to combine to form big F, and also we've got another big F. So there's a 50% chance the child will actually be completely healthy, not even a carrier, no problems whatsoever. But because of this little f, there's a 50% chance that it'll be big F, little f. So there's a 50% chance the baby will be a carrier. Now the baby won't be a sufferer, so they won't have it, but they'll be a carrier. Now if they were to get with somebody in the future and have a baby of the same genotype, then that would be a problem, okay? But in this situation, none of the babies would actually have cystic fibrosis themselves. So you've got three scenarios really. You're either completely healthy, big F, your big F, little f means you're a carrier, or worst case scenario, you're a little f, as in you're a sufferer, you have cystic fibrosis. Okay, last scenario. So scenario 2 is not so rosy now. So just like we've discussed, so we've got a father who's a carrier, big F, little f, and we've got a mother who's a carrier, big F, little f as well. Okay, and what that gives us is these outcomes here. So you can see we've got another big F there, so 25%, so as in 1 in 4, okay, or 0.25, 25% chance the baby will be completely healthy. You've then got the big F, little f twice, so that's a 2 in 4, which is a 50% chance of being a carrier. And then obviously this is the bad situation here, the bad scenario, what little f, there's 1 in 4 or a 25% chance the baby will have cystic fibrosis. So if those parents knew their genotypes, they'd have to weigh up all the options there. Okay, so overall there's a 75% chance, either 3 in 4, the baby won't have it, and a 25% chance that the baby will have cystic fibrosis. Okay. Now, of course, remember in the previous video we're talking about percentages. Sometimes you get questions about, what ratio, what proportion, what probability, what percentage. So you've got to make sure you give the right number in the right situation. If they were asking for, say, what fraction of these babies could have cystic fibrosis, and you said 25%, well, that would be wrong, because 25% is not a fraction. You have to say 1 over 4. Okay. If we're talking about ratios, it would be a 3 to 1. 3 to 1, 3 healthy, 1 with cystic fibrosis. Okay, now just a couple of more terms bring back from a previous video. Remember, if we've got the two letters are different, so big F, little f, remember that's called heterozygous. Okay, and if we've got the two letters the same, big F, big F, if they're the same, that's called homozygous. Okay, and remember the letters represent the alleles, so that's known as the genotype, and the phenotype is what would happen in real life. Are they healthy, are they a carrier, or are they a sufferer? That would be called the phenotype.